Hello friends, welcome to my channel. This is Isro Engineering Mechanics Part 7. Two equal forces are acting at a point with an angle of 60 degree between them. If the resultant force is equal to 60 root 3, what is the magnitude of each force? We know resultant R is two forces P square Q square plus 2PQ cos theta root over. So here resultant are given 60 root 3 and two equal forces P equal to Q. Let it be P. Angle theta given 60 degree. Magnitude of each forces we have to calculate. So 60 root 3 equal to P square plus Q square plus 2PQ into cos 60 root over. So squaring 3600 into 3 is P and Q both value same, P square plus P into Q is P square, cos 60 is 1 by 2, it's 3 P square, 3 cancel, P is 60 Newton, unit not given, so P is equal to 60. D is our answer. Forces P and Q, this is our resultant force R, angle is theta. A two-member truss ABC is configured as shown in figure. The force in the member AB is how much? Force in the member AB. Here we have to calculate the force. If we draw the free body diagram, it will come like this. Here this is compressive force. So we can write it here also. This is FBC. Here it's tensile FAB. We have to calculate FAB, force in the member AB. So here we'll draw at B point. Here let this angle be theta. Here it's theta. So tan theta is 0.5 by 1. It's 1.5. Tan theta value is 1.5. Here it's theta, and we already got theta, tan theta value. Here given 10 kilonewton. FAB we have to calculate FBC. Along y direction or vertical, summation of all forces is 0. So FBC into sin theta equal to 10 kilonewton. So FBC equal to 10 by sin theta kilonewton. Along horizontal direction, FBC into cos theta equal to FAB. We have to calculate this one, FAB. Force along AB. FBC, here we got 10 by sin theta into cos theta, or 10 by tan theta. Tan theta we already got Here it's 1 by 2. So 10 by 1 by 2, it's 20 kilonewton. From option C is our answer. The force in the member AB or FAB equal to 20 kilonewton. Four forces of magnitudes 20 Newton, 40 Newton, 60 Newton and 80 Newtons are acting respectively along the four sides of a square ABCD as shown in figure. The magnitude of resultant force is how much? So first we will take, for calculation of resultant, summation of all horizontal forces. Take right direction positive, left negative, upward positive, downward negative. So in x direction 20 minus 60, it's 40 Newton. Along y direction or vertical 40 minus 80, 40 Newton. It's towards left, it's minus, so towards left. Here also it's minus, so downward direction. We have to calculate resultant force. Sigma x square plus sigma y square root over 40 square plus 40 square root over. So 40 into root 2 Newton is our resultant force magnitude. 40 root 2 Newton. A is our answer. A thin wire of length L and uniform linear mass density rho is bent into a circle with center O as shown in figure. The moment of inertia of the loop about axis x dash. Moment of inertia we have to calculate about this axis x dash. So given L equal to 2 pi r, thin wire of length L and its area of cross section is negligible. It's thin, so it's negligible. And we know along CG, if we will calculate area of moment of inertia of thin wire, it will come pi r cube, r is the radius, into T. And for ring, we know mass moment of inertia at O is mr square by 2. For Ixx, we will use parallel axis theorem. Ix, it's Io plus mr square. So it will come 3 by 2 mr square. Io is mr square by 2 plus mr square. It will come 3 mr square by 2. And we know L equal to 2 pi r. From here r equal to L by 2 pi. We'll use this one. Ixx dash is 3 by 2 into m into r square. We have to use L by 2 pi square. So it will come 3 by 2 m into L square by 4 pi square. And one more thing we know, mass equal to density into volume. So here rho into L is length and area of cross section. Area of cross section is negligible. It's a thin, so it's negligible. So m is rho into L. Here we'll put L value. Let it be equation 1, equation 2. From 1 and 2 we'll get Ix x dash is, put the value of m, 3 by 2 m is rho into L into L square by 4 pi square. It will come 3 rho L cube by 8 pi square. From option 3 rho L cube by 8 pi square. D is our answer. A 10 kg mass is hung from two light inextensible strings as shown in figure. The tension in the horizontal string is nearly how much? Draw free body diagram. See W. Let take points here A, B. Here at CG, C. A, B and C here. This angle given 60 degree. So this is also 60 degree. Again if we will draw W, F along, force along A, force along B. This angle is 60 degree. So if we will calculate summation of all forces along, we have to calculate tension in the horizontal string. So this one we have to calculate. FA. First take vertical direction, y equal to 0. FB into sin 60 equal to 10 into G. W is mass into acceleration due to gravity. So FB equal to 10 into G by sin 60. Question 1. Along x direction, FB into cos 60 equal to FA. We have to calculate FA. So FB value we already got from equation 1, G by sin 60 into cos 60. So 10 into 9.81 into cos 60 is 1 by 2 into divided by sin 60. It's root 3 by 2. 2 cancel. It's 8.1 by root 3 is 1.7. It's 981 by 17. So 1 by 17. 17 into 5. That's 85. 13. 131. So it's more than 50. So A not possible. C also not possible because first 5 will come. D also not possible. 57. No need to calculate exactly. Approximately 57 Newton. All got. B is our answer. In 1 second, a particle goes from point A to point B moving in a semicircle as shown in the figure. The magnitude of the average velocity is how much? Body is going A to B in 1 second. Here speed equal to distance by time, and velocity is displacement by time. So here in this question we have to calculate velocity. Displacement is A to B. A to B, its radius is 1 meter, so 2r. Diameter is 2 meter by time is 1 second, so it's 2 meter per second. From option C is our answer. If they will ask speed, then we have to calculate the distance moved. This curve we have to curve is 2 pi r by 2. It's pi into r by time 1. So r is 1, pi is 3.14 meter per second. If they will ask for speed, then A will be our answer. But they ask for velocity, so C is our correct answer. A block is made to slide down an inclined plane 30 degree with horizontal, which is smooth. It starts sliding from rest and takes a time t to reach the bottom of the plane. An identical body is freely dropped from the same point. The time the body takes to reach the bottom is how much? We have to. Here we know potential energy is converted to kinetic energy. From that we will get V equal to root over 2gh, that vertical height. Here let it be h. And this question both we have to consider. This one V depends on h, height, and one in inclined path and one is vertical path. So one more formula we have to use. Velocity is distance by time. Speed is distance by time. Distance is s and time. And time is distance by velocity. And here h1 sin 30 equal to h2, inclined motion to vertical motion. We will calculate t1 by t2. We will take inclined motion as 1 and freely dropped is on 2. We have to calculate t1 and t1 by t2 ratio. So its distance is, in case of t1 it's h1, distance by velocity v1 divided by distance freely falling h2 by v2. We know from here v depends on the vertical height. Here vertical height is same both cases, so v1 v2 we have to cancel, so h1 by h2. Here we already got, this is h1 by h2 is h1 sin 30. Sin 30 is 1 by 2, it's 2. 1 by 1 by 2 is 2. So t1 equal to 2 t2. In this question, first the time is t. So t1 is t. I have to calculate t1 given small t. So second one is small t by 2. From option it's B. B is our answer. This is the end of engineering mechanics. Thank you friends. Thank you for watching my video.